Hi, I'm Grant from Blackmagic Design, and today I'd love to update you on a new technology called Blackmagic RAW. Now, it's a bit of a technical update, really, because I wanted to explain, really why we've developed our own RAW format and kind of all the details about it. Now, we've been working on this for over 2 years now, and in some ways, it sort of started with the original Blackmagic cinema camera. You know, that camera had a wide dynamic range, but it also used open standards. Yeah, we felt open standards were pretty important, and on that camera, everything was open. You know, we had an EF lens, we had an SSD, we used normal ProRes files. These are all standard things. Also, the camera used Cinema DNG for its RAW format. You know, everything on that camera was open. The problem is, though, is that when it came to Cinema DNG, that format's a bit of a nightmare. It's made up of still frames, and it's really kind of a dumb bucket of pixels type format. It's really just a container of pixels. It doesn't really know anything about the camera. So, you know, in a lot of the, to make it work, what we did is, so it kind of looked open, but it wasn't really. What we did is we got sort of hacks into DaVinci Resolve to make Cinema DNG work. You know, all the color science and everything was in DaVinci Resolve. The problem is when you opened up Cinema DNG files and other apps, they look really bad. And in fact, it's worse because they're open. You can open them up in, like the Finder and things, and they look really clipped and bad because the color science is all built into DaVinci Resolve. So what that kind of meant was that people only really used a RAW format when they had to, like, if they're doing high-end work, like television commercials or films. So it was pretty clear we needed a new RAW format, one that was sort of easier than the older RAW format, but better quality than video formats. And the result is, the result's Blackmagic RAW. It's a format that's easier to use and much better quality than video formats, but it's got all the benefits of RAW recording. You know, it's very easy to use. You know, ease of use is very important. We want to try and open up RAW recording to everyone. And, we really it'd be nice if all the work could actually bypass the 4:2 video filtering, because that video filtering is quite damaging. It's quite bad. It kills half the color detail. So if we could come up with a new format that could let you to bypass that, you'd be able to use RAW for a lot more work. So I think what it might be worth doing to start with is I might explain the design goals of what we wanted Blackmagic RAW to do. We kind of thought about it as a larger problem, and we started to sort of think about, okay, well, what's all our wish list of all the things we really love for it to do? So obviously the biggest item is we wanted a single file for everything. We didn't want a folder full of frames. We really also wanted a new format to replace the RAW and video formats that we'd always, already been using. We also wanted better quality images, even when running much higher levels of compression. We wanted a format that was intelligent, and it could understand the characteristics of both the camera and the sensor. So this means Blackmagic RAW is not just a simple codec that's only a container for raw data, but it's much more intelligent as it understands the sensor in the camera. The other thing we've done is anyone can read the files. We've built a developer SDK library, which is like a module, a software module, and we've designed it to be very easy for anyone to add it into their own software applications. This SDK library will be on every Blackmagic camera installer, and you can also download it from the Blackmagic RAW site, which is actually will be on the Ursa Mini Pro's website as a tab on there. The other design goal that we had was to make sure that the images look the same between applications. We wanted complete consistency between software as well as Mac, Windows, and Linux. And so, like, a really good example is, we wanted to allow, if you adjusted the RAW settings in one app, we wanted those settings to be carried across into every other app. So that's a pretty powerful feature. Another big thing we were looking at doing is we wanted to make Blackmagic RAW extremely fast. Essentially what we were trying to do is make the world's fastest RAW file format. And that's a big thing as the sensors are getting larger and raw data is getting more complex. The other thing we wanted to do is we wanted to eliminate the sort of expensive hardware decoder boards, which is really important if you're using it on a laptop. You don't really want to be able to have to plug in sort of any custom hardware. Another really goal for this format, for the Blackmagic RAW format, was we had to design it so it was easy to add into the Blackmagic Design cameras. We're going to be starting with Ursa Mini Pro, but we're going to add it to other cameras like the new Pocket Cinema Camera 4K and other cameras soon. And lastly, obviously, is we wanted a format that was free of patent issues. And in fact, we've got a bunch of patents happening on the technology we've developed in Blackmagic RAW. So I think that was really our design goals. So let's take a quick look and see how all this works. Now, what I've done is I've got a bunch of blocks here on the table, and I've made the blocks represent each stage of the image processing that you have to go from the sensor all the way to a final image. Now, what this is representing is the older Cinema DNG file format that we've been using. Now, what I'll do is I'll explain what each block does. Now, this block represents the sensor, which is in the camera, obviously. This one's the encoder, which is, can add a bit of compression, or if, in case you're using sometimes no compression. The files here, this is the block representing the file. In its case of Cinema DNG, it's a folder full of frames. Here's the decoder, and this uncompresses any kind of compression that might be used upstream here in the camera. And we have a full demosaic, which is basically the bit that turns the sensor data into imagery. Can be quite complex. And then we have color, balance, and gamma. Now, this is where we have a lot of stuff in DaVinci Resolve in the Cinema DNG format to do all the color science stuff. These two are very, very difficult to do very well. Now, the way this is represented, this bit is in the camera, and this bit is in the software. Now, the demosaic, as I was saying, needs really heavy processing. It's much worse when you're doing lots of layers, say in video editing, and also lots of color correction. A good example is, DaVinci Resolve will do a fast debay when you're editing, but then do a much higher quality one when it's doing a final output. And in fact, there's a few different debayer algorithms in DaVinci, and there's been a lot of research done by the DaVinci Resolve team to get that quality better and better all the time. That's why it's used in most of the Hollywood films. Now, the alternative way that that we have experienced this is that we can do it all in the camera using a video codec. So with video, pretty much the whole lot's done in the camera. But the problem is the color detail is killed because you've got the 422 compression, and the 2 and the 2 are actually the color channels, and they're half the bandwidth of the black and white part of the image. So you get a lot of color detail that's killed. Also, compression artifacts are more noticeable in video files because you're compressing the final image, and so you can really see if there's any defects in the final image itself. So now Blackmagic RAW is different. What we've done is we've moved part of the processing into the camera. So I'll show you what we've done. So the first step is I'll take out the full demosaic because we've split this into 2 processing stages. We've done a partial demosaic, and we've put that just after the sensor in the camera itself. And then it means we can use a reduced demosaic in the software. So that's the pipeline for Blackmagic RAW. Now, so what this means is that part is in the camera, and this part is in the software. And we've essentially moved the heaviest part of the processing to the camera where it can be hardware accelerated. The hardware accelerating the heavy part of the raw processing in the camera is why Blackmagic RAW is so fast. This processing is perfectly optimized for the camera sensor because it's actually in the camera itself. Now, this is not a simple generic RAW processor. It doesn't have to handle any other type of camera, just the camera that it's in, just this one. So, and of course it would be different on different cameras, but it's, that bit's built into the camera. So it knows exactly everything about the camera and everything about the sensor. Now, these parts of the processing, which is the decoder, the reduced demosaic, and the color science, are all processed in software. The images are still in a very raw form, so you get all the flexibility of the raw adjustments and, such as ISO and white balance and everything like that, but the amount of work that the software has to do is much, much less. The software doesn't have to do all these sort of heavy calculations to get the quality of the debayering, but at the same time, and also the benefits. So it just doesn't slow down the software as much because we've done part of that in the camera itself. The other thing is we also get deep bit depths. The sensor can provide much more than 10-bit bit depths that the video file formats use. And so we get all that through the pipeline. But that's not all. The other thing we've done is we've added a whole bunch of metadata to the file. So the software downstream knows everything about the camera's settings. I mean, it knows everything. What's most important though is it knows the color science. It fully understands the sensor characteristics. It knows everything about the color science of the camera. So what this means is the SDK library can handle all the sensor's characteristics, so any downstream apps can intelligently understand how the sensor responds in different situations. Another benefit is that all the processing is contained in that SDK, so it's available for any developer to add to any other software. You just build the library in and it works. Also, the processing uses both the CPU and the GPU. So, but where it gets interesting is the compression is before the raw conversion. So what this means is you get much higher compression without degrading the image quality. You're not compressing final imagery, you're actually compressing the raw data before it turns into imagery. So it's much easier to decode without image artifacts. So what's really interesting is we've been testing with a bunch of DOP friends, and they've been using like the maximum 12:1 compression, and they haven't been able to see any artifacts, which is really quite incredible. We've been quite surprised. Actually, the feedback coming back has been a bit of a shock. So I thought it might be worth actually pulling up a few slides. It's not something we normally do in a video, but I thought the feedback from the beta testers was quite important. So let's take a look at some of the comments that the beta testers have said about Blackmagic RAW, because I think it's quite interesting. Here's a comment, wow, I've seen some tests, I've shot some tests this morning, deliberately aimed at picking up compression issues, and I'm having a lot of difficulty identifying any visual difference between all the Blackmagic RAW options, which is really quite surprising. Some of this feedback kind of shocked us a little bit because you get so busy with the technology, and then when you see this sort of feedback coming in, it's quite good. Here's another, if we can cut to the other slide. Even at 12:1 and Q5, the images are absolutely stunning quality. I'm also seeing a massive improvement in the noise. 2, this doesn't look incremental. It's almost as big as seeing footage from a different sensor, which I think is exciting. I think that shows that it's transforming the quality. Here's another slide that if we can bring that up. After testing extensively, I've yet to see any reason to avoid using 12:1. In fact, when I look at it versus other codecs, it's a no-brainer to use this new camera codec, which, again, this is another thing that really kind of surprised us a bit. 12:1 is the maximum compression level at the moment. It was a bit of a surprise to see that everyone just started using that level and got really small files with a high quality. And then there's another slide. Really loving this new codec. Such a great combination of RAW control with non-RAW file sizes, which is pretty much, I think, sums up what we were trying to achieve. So it shows we're getting these incredibly small files plus great quality, and it's good to see this feedback on real-world tests. I think sometimes you don't really know what you've developed when you're focused on the technology, and then you see people actually use things creatively, and it's really nice to sort of bounces out and kind of almost tells you what you've really achieved. So, of course, we've got all the RAW adjustments. It's a professional workflow. It's fast, easy used, small files. So I think it's a really, we think it's achieving the goal we had, which is it's a great first choice codec for shooting all kinds of work. It's a good replacement for RAW codecs and also video codecs. So you can sort of go to it as the first choice when you're working. Now, we've also changed the way you use the codec. The settings are different. We haven't used sort of names for, like sort of made up names for the settings. We've actually tried to use setting names that are relevant, like relevant names for the codec settings. So, for example, we've used numbers like 3:1, 5:1, up to 12:1, which are simple ratios. I think that's more logical. It's better at describing what the codec's actually doing. Now that's the constant bitrate setting. The codec, Blackmagic RAW actually has 2 different ways of running the codec. Constant bitrate is the most common. That's what most codecs do. It keeps the data rate consistent. Now that's really good for video work, when you're shooting video, but I didn't think it was really good enough for RAW work. Like, what happens if a shot needs more quality, but the bitrate can't rise to accommodate it? This could be very bad, as the codec would have to start compressing harder, and you might not notice until you've got a quality problem until you've returned from a shoot, and it's too late. So we kind of felt like we needed an alternative. So Blackmagic RAW has an alternative that we call constant quality. Now, technically, this is a format is a variable bitrate format, and what it does is it encodes the data without really caring what the file size is. It just grows. So if you're shooting a complex scene that requires more data to encode, then the file size will just grow to accommodate it. It's not going to compress harder, as it's not trying to maintain like a fixed data rate. So let me show you on the camera. If you can cut to this camera here, I'll move out of the way. And I'm going to show you what this looks like in the menu. So if I come down here and go to the settings, and you can see we've got Blackmagic RAW there. We've also got ProRes and DNG. Now you can see the different quality settings there I can change. That's because it's set to constant bitrate, but I can actually change this setting here and go to constant quality, and you can see there's a Q0 and a Q5. So we've got the 2 modes. So as you can see, I've shown you that you can change between them. Now, I changed between Q0 and Q5 because that's kind of like the number that goes into the compressor stage. So it's a different kind of number because it's a different format. But these are sort of relevant names back to what's actually going on. It also differentiates. You could say to someone that it's Blackmagic RAW Q0 and they'd know that it's a constant quality codec using the Q0. So it also helps you describe to somebody if you're doing a shoot and you need to let the post-production guys know what you're working in. So this is the mode that'll just encode at a fixed rate, and the file size will change based on the kinds of images that you're shooting. Now the file size can sort of grow and shrink automatically. So sometimes the files could actually be smaller if the shot allows it. The only downside to this type of encoding is you could also get a data rate that's so high that the media can't keep up. However, in that case, I think you'd probably want to know immediately if you've got an issue, and then you can investigate what's happening. I think it's better to know if you have any problems on set, not later, kind of after the shoot. So, but it's really your choice what codec you use. The default is constant bitrate, and that's what most codecs do. But you can experiment and try it out for yourself and see which mode you think you like. It's funny actually because the beta testers have suggested adding even tighter compression settings because they can't see any of the artifacts. However, we think that it's probably not something we should do straight away, but maybe later we could check that out. So that's how the settings work on the camera. You see it's pretty easy, it's just another choice. So the other thing that's probably worth mentioning is there's a bunch of other features in Blackmagic RAW that are pretty important. There's a lot of things it can do. I sort of talked about some of these in the design goals when I was mentioning that, but there's really a lot more information on, and there's a lot more information on what Blackmagic RAW can do on the Blackmagic RAW page, and that's on the Ursa Mini Pro website. You can read up a bit more of the technical details, but I'll cover a few of them here before sort of finishing the video so you can get a bit of a wrap up on some of the extra capability because it's kind of interesting. As I mentioned, Blackmagic RAW is a single file, so all the images, sound, metadata, and the sensor information are stored in a single file. So it's very fast to copy the media around. Copying still frame files are much slower than copying a larger file. So the media copying is much quicker. And we have a simple Blackmagic RAW player that you can use to review clips. And if you cut over here, I've got a computer on the desk here you can cut to, and I've got a few Blackmagic RAW clips on here. So let's have a quick look. So if I open up, you can see there, here's a clip here, and you can see it's very fast. I've also got a full screen mode that I can go to. I'll show you the other clips here. You can see there. And I've got no eGPU connected on this machine either. It's just playing. And you see they're very fast. And here's another one. And you see some, really beautiful cinematic looking images. Look really, really quite amazing. So you can see that's very fast. We've achieved a really great full resolution decode speed. And from our tests, we think that Blackmagic RAW is the fastest non-hardware accelerated RAW format currently available. When decoding the frames, the CPU acceleration out in the SDK library, it supports all the main architectures, including AVX, AVX2, and SSE41. Of course, it also supports GPU acceleration via Apple Metal and NVIDIA CUDA and OpenCL. It also works with the new Blackmagic eGPU for extra performance, but we don't have one plugged in here. It doesn't really need it, which I probably shouldn't say. So we've also developed support for Mac, Windows, and Linux for the SDK library. And the Blackmagic player that you just saw there is available on Mac, and it'll be on Windows soon as well. Now, the next thing I'd like to show you is we've got human-readable sidecar files that can be associated with the clips, and they have additional metadata that's on top of the file metadata. So when the camera is recording, the camera generates its own metadata, which gets embedded into the file itself, but the sidecar files can override the embedded metadata. So you don't have to change the metadata in the file, you can just add on top. And the metadata has all the raw settings, but it's also got things like iris, focus, focal length, white balance, tint, color space, project names, things like that, take number, a whole bunch of stuff. So what I could do is we could cut back to the file, and I'll show you this. These sidecar files were actually generated and have been used when I opened up the clips. But if we could try removing one, and then you can see what it's doing. So if we go back to this clip again and open it, you can see that's the image. Now that's had some raw settings changed on it. If we close that and move the sidecar file out of the folder, now it won't be able to find that sidecar file, so it'll go back to the raw metadata that was in the clip itself. So I'll open that up now. If we can cut back to the computer, you can see. So now it's a very flat film gamma type image. You can see the effect that the sidecar file is having. So I'll put it back in, and there it is. And you can see now it's picked up the sidecar file automatically, and the Blackmagic RAW library, the SDK library, is doing all that work. So what it means is you can add this extra metadata to a file simply by sort of adjusting the raw settings in an application, and then you can save those raw settings. And these clips had their raw settings adjusted in DaVinci Resolve, and that automatically created these sidecar files. So what I can do is I can actually now show you that in DaVinci Resolve. So I'll switch to DaVinci Resolve, which I've got running automatically in the background here. There it is there, there's the edit page. And you can see actually, I'll just play, you can see it all plays nice. We've got no eGPU on this machine, it's just playing these files like nicely. I've even got a screen, the feed you're watching is connected to the computer, just on the HDMI out. So if I go to the color page and I click, so you can see the normal color wheels will be here, but if I go to the camera settings over here, and you can see all the metadata settings. So if what what I can do actually is, let's change the RAW settings, and you can see how the effect that has in the other applications. So what I'll do is I'll go into here and I'll change the ISO to 1600. You can see it's made quite a change, and I can just update the update the sidecar file. Now, any software that supports the Blackmagic SDK would have these settings if the application vendor puts them in, but definitely you can read the files. So now what I'll do is, now I've done that, I'll hide DaVinci Resolve. And if I go back to this clip, you can see now the Blackmagic RAW player has picked up the higher gamma level setting, the ISO setting that I changed, and you can see it there. So if I quit this and go back to DaVinci Resolve, I could change it back and then update the sidecar, and it automatically will have picked that up, and you'll see that the difference is there. So you can see it's quite interesting how it does that. So I'm not going to really go into a lot of details because the video will get too long, but all the changes you do in DaVinci Resolve are saved in the sidecar file. So it means you can go back to the original metadata or use the sidecar metadata. It's up to you. And that's how other software applications can see the metadata, because they'll pick it up. If they build in the Blackmagic RAW library SDK, they'll get all this capability for free. It's built in, and it handles it all for them. Now, these sidecar files are human readable. You can open them up in a text editor, which I'll do. So I'll go, if we can cut back to the screen, and I'll open up with a text editor, which is Text Edit on a Mac. And you can see that there's a whole bunch of settings information, and you can kind of hack that. You can see there's a lot of raw details there. Now, actually, I might zoom it up a little so you can see it. Oops, there we go. Oops, I've got I use the trackpad the other way around than what they set to the default these days, but you can see it there. Now, what's also interesting is you see these timecode values in the metadata file. You can animate the metadata over time, and that's good when you're tracking like a lens during a shot, and you want to actually be, saving the lens position like live into the metadata. So even when you're shooting, like this is what's really interesting. Even if you're shooting video gamma, the file stays in film gamma. So the metadata just tells the Blackmagic RAW processing to use video gamma. So that means anytime you want to pull up like the black parts of the image or pull down the white areas, if you're color correcting, the detail's still there. Nothing's ever clipped, even when you're shooting in video gamma. So using video gamma images are great because they don't need color grading. So it's very fast to work, because obviously if you're shooting film gamma, you need to do color correction. But if you're shooting in video gamma, you don't have to do that. So it's very fast if you're doing documentary work and things like that that are quick. But the images in a video codec are clipped, whereas in Blackmagic RAW, they're not, which means that you've still got all that detail there. If you pull down the whites, you've still got detail. If you pull up the blacks, you've still got the detail there. So you've got almost a video workflow, but hidden in the background is always the fact that the file still has all the dynamic range in it, and it's always still there. And then the day you need to use that, you can instantly access all that extra dynamic range of the file. So I think it's pretty exciting. So the sidecar files here, they're overriding the metadata. It could be stored in the file. It gives you a lot of control. And so all this sort of combines with a new advanced debayering we've also got, which allows the noise and edge handling to be optimized for each sensor, and that's because it's getting that information. This is one of the reasons why we're seeing such big improvements in the quality of Blackmagic RAW when compared to the older kind of Cinema DNG RAW format. And it's because Blackmagic RAW is basically just more intelligent. That's because it handles, the debayering process is complex. It can tailor that to each sensor. And so you get the benefits of being able to use much higher compression ratios without losing quality. There's also other things in the format that are worth quickly mentioning. There's user customizable color space transforms, so you can create your own preferred color spaces with control of things like saturation, contrast, mids and highlights and shadows. What else? The Blackmagic RAW SDK library also includes the Generation 4 color science, so you get really nice organic sort of cinematic images with any app that supports it. So it's like it's really very cinematic looking. It's really quite nice. It's like a whole new camera. So anyway, that's kind of a quick overview of Blackmagic RAW and some of the details and how it works. I think it's going to make RAW shooting really easy, but also obviously better quality. As far as supporting other brand cameras, there's been a bit of talk about that, and it's certainly possible. We need to do some technical work on profiling sensors, so it's something we could work on. One thing that's actually probably worth noting that I haven't mentioned, you can also render to the Blackmagic RAW files. So you can consolidate jobs when you need to export out you know, like a DaVinci project or a project with all the handles, with media with all the handles on it. So you can sort of bundle the whole thing up, re-render the files, it reprocesses them, plus handles, and then you can get that whole package off to like a facility if you need to send it out to a third party. And that could be important if you get like funding for a project. Maybe you start a project as an indie project and you get some funding for it. So you want to move it to a larger facility so it can get like color graded and then released. So anyway, to summarize, we'll be releasing Blackmagic RAW today as a public beta for our Ursa Mini Pro cameras. And you can just go to our website now and download it free of charge. So what this means is that any Ursa Mini Pro owner can download this update and get both the Generation 4 color science and the new Blackmagic RAW free of charge. Just download it. It really transforms the camera's image quality, and it's like getting a whole new camera. It is a public beta, but I definitely reckon it's worth going and getting it. It's really a whole new level of cinematic image. It's much more than this is much more than a simple RAW container format, because it's intelligent, and that's required for high level cinematic images. I think, you know, it's there's so much in this. It's hard to sort of explain it all because it gets quite technical. Also, we've posted an update of DaVinci Resolve 15 today. I think it's DaVinci Resolve 15.1 that includes support for Blackmagic RAW, so you can also download that today as well. And we've also got some sample clips on the website too. So I hope you can download it and give it a try. And also let us know what your thoughts are and any features you think you'd like to see added to the format. Also, I'd like to quickly, before I finish up, thank all the beta testers who've been working with us and working with our engineers to get this working so well. You know, their testing's been invaluable, and like I was saying before, you know, you don't really know sometimes what you've finished until someone uses it creatively. You know, we're half of the overall kind of, you know, product. The things that you can do with it is the other half. So until you see what creative people can do, you know, cinematographers and photographers can do with these technologies you generate, you often don't know what it all kind of means. It's really nice to get that feedback. So thanks a lot, guys, for all your help. And of course, I want to personally thank all the engineers here at Blackmagic. We've spent, I think, about 2.5 years now working on this. You know, I think when you see the pictures coming in, I think all the guys really understand what all those thousands and lines of code are for and what all the technology makes possible. It's really exciting. Now, we'll be working hard to add Blackmagic RAW to the new Pocket Cinema Camera 4K, and as well as some of our other cameras as well as future updates. So, look, I hope this update's been useful and you've got everything you kind of need to know about Blackmagic RAW. And I hope to see you at a trade show soon where we can continue all the exciting discussions we normally have. But that's about all I have for now. So thank you very much for watching, and talk soon. Bye.